meetup for basically all things DNS. CloudFlare was hosting the very first one with DNS inventor Paul Petrus, and today we are very honored to have Dan Kaminsky. So I will pass this over to Gandi to make all the appropriate introduction.
Hey guys, if you guys have not heard of Dan Kaminsky, he is the most badass hacker in DNS. I became first interested in DNS because I heard of a hack that Dan Kaminsky found. But what's really cool about him is that he's stayed very involved in policy as he's found more and more security vulnerabilities. So we're really lucky to have Dan here. So thank you, Dan.
Happy to be here.
Cool. Give it up for Dan. Cool. Oh, something I should say. We should keep this really casual. As you have questions, just type up and ask, or if you want to be formal about it, like throw up your hand, but it's not that necessary. It should be an open Q&A. I have questions here, but you probably have a lot of questions as well, and so you should ask them too. And we have sections, but take them as a light suggestion, and you can ask out of order too. So first, Dan, we want to hear about you. When did you first get into programming?
I don't know, it was like 4, it was like a handy color computer 2. Got my Rainbow magazine and typed in programs from the paper.
Tell us more.
No, it was just one of those like kids that got a computer when I was really young. And it's like, oh well, I can do this. It was fun. Look, the screen's flashing. It's doing what I want.
And what was your first hack? Like the first piece of code that you ever broke?
First piece of code I broke. So I show up at Cisco as an intern, like 99, and they give me control of this giant, like, I don't know, $25 million lab, and they're like, all right, kid, you're running this. So stuff started falling over immediately. So like, hey, can this be like my job? Hey, you know, we don't care, kid, you can do whatever you want. You're like free to us, the most valuable company in the world. So I kept up with the lab, started working actually. We had to tunnel our way into all of these various networks to go ahead and get them fixed. And, you know, a lot of over the river and through the woods stuff. You know, it's like dial into this system and then tell it over here, and then there's like a serial device, and you have to like initialize it like this, and after all of these steps, then you get a prompt at the machine that you want. And I'm like, okay, this is insecure, and we need to access the web interface. And we've got like 7-bit ASCII. How do we do that? So I ended up starting to work on OpenSSH, wrote some patches for it. You know, it's funny, for all the stuff I've ever done, my most popular code was written when I was 19. The $D flag. It says if you can possibly get an SSH connection to something, you can now get web access because it'll create what are called dynamic port forwards. So SSH can be squeezed through everything. And then once you get there, here's your web interface and it's over the world.
Thank you very much for this.
So how did you find the cache poisoning attack in DNS? Can we get a play-by-play?
So, funny story, try to make the internet faster, okay? Who here's familiar with DNS? All right, guys. You know that whole like thing where it takes like 72 hours for stuff to propagate? So that's a big pain in the butt for content distribution networks. So I'm sitting with Artur Bergman. He would eventually go on to found Fastly, but this was at this point years away. And we're trying to discuss how would we get around this 72-hour delay in DNS, which isn't really 72 hours. It's really who the hell knows. Yes, could be more. DNS, not so much with the push thing, right? And as it happened, I actually had a trick. It involved CNAMEs, it involved sibling names, and if you basically had a sibling name, be like, okay, you looked up random.google.com. By the way, also, you know, Google.com itself is at this new address, it would work most of the time. So, we have this discussion, it works out okay. Then I get to thinking, man, that can't work. Because if it works, we have this thing, the DNS TTL, the time to live, and it's actually like really important for security because there's only overwriting DNS cache entries is a lottery. Winning the let me restart this. You send out a request for a DNS name, something's going to come back. Hopefully, it came back for the person you're talking to. The value is only 16 bits. There's only 1 out of 65,000, so it's like lotto with 1 out of 65,000 odds. If something's worth more than $65,000, might go ahead and raise that money and go ahead and buy all the lottery tickets. This is kind of the same situation. What if someone just went ahead and just flooded with fake responses? They don't know the number, but there's only so many numbers. The hope was that you could only, quote unquote, play the lotto once a day. Or that was actually going to be the advice, that you should have long TTLs of anything of high value. So if it's a day, it's going to take you like 83 years to win the DNS lotto. And that's okay. We'll deal with that. This trick I had come up with Artur, or that I had actually come up with long before, would totally get around that. Because there's an infinite number of sibling names. It's like 1.google.com, 2.google.com, 3.google.com, and any of those could overwrite Google. Like, this can't work. If it works, we're screwed. So we were screwed. No, we're like immediately. Like, there's not like moment. There's totally this, call up my girlfriend at the time. I'm like, honey, I broke the internet. This actually happened. And yeah, so that's kind of, then things got complicated.
So then things got complicated.
So, have any of you guys ever met Paul Vixie? Paul Vixie's like one of my favorite people in the world, okay? I'd done various DNS stuff in the past. It was always, small and silly. I streamed video of Darth Vader dancing over DNS to show it was possible. Stored entire CD-ROMs in DNS caches because I could. Hey, a little bit of bytes, but millions of servers. It scales-ish. So I've been friends with Paul for a while, and if you know him, this is like the most chill guy in the world, okay? Like, nothing phases this guy. So I call him up, I'm like, so Paul, there's a bug. He's like, how bad could it be? And then like 5 minutes later, he's like, never talk about this on the again. And I'm not joking, like he's not one to panic, but then I learned this is what Paul Vixie panic looks like. We ended up with this like super secret meeting at Microsoft headquarters about a month later. Like people had flown in from around the world. A quarter of the people who flew in did not know why they were flying in. They were just told, you gotta go and you'll find out why when you get there. But hey, you know what? We walked out of there with a plan and the plan worked.
So what happened at that meeting? Can you tell us?
Pretty much got up there and showed them the attack working. ISC went up there, confirmed how flexible the thing was, confirmed there wasn't a trivial fix, and Paul got up on stage and he's like, we should have listened to Dan Bernstein in '99. And, I really think that was like a significant part of this. Like, that's a hard thing to say, but it really underscored the point, no, we gotta do this. And by the way, it makes name servers a lot less elegant, a lot more ridiculous to write. Kernels are not really compatible with efficient, efficient source part randomization. So it's not like there wasn't a reason we didn't do it before, but now it was clear we had to.
So where do you go from there? How does the DNS community start to address it?
Well, the first thing was actually going ahead and making sure that all the major vendors and name servers were aware of the issue, had some concept of what to do. And it wasn't obvious what to do for all servers, right? Like I said, the kernels really don't like source port randomization and efficiency at the same time. They really want to just have like a socket that's open and reuse it all the time. Turns out we needed that entry. So Unix servers went one way. I was actually consulting at Microsoft at the time. So the Windows solution involves a socket pool. It pre-allocates a bunch of sockets, and then they're already good. So you're not dynamically reopening them all the time. And that's what works on that platform. But it was very much, one, figure out how we were actually going to solve it, which wasn't entirely obvious. Two, synchronize on the release. Like, when were we all going to talk about this? And I'm going to admit, it was somewhat of a hope that we'd have a synchronized release. I sort of assumed someone was going to leak. Like, especially once we started bringing in the antivirus guys, the other network security people. That was about a month or 6 weeks before the public release. I kind of thought it was going to leak out, but no. Everyone was like super professional and super responsible. We had a synchronized release across Windows, Unix, and iOS, and Cisco iOS within minutes. And that was what I thought was cool. I actually didn't want to name the bug. I'm like, who cares about the bug? That was like 2 days of checking stuff out. We just spent the last 6 months doing a massive multi-vendor patch. That's the cool part. And so they just ended up naming the bug after me. Crap. that part didn't go according to plan, among other things. This was 2008. This was early July 2008. Came out with the, we didn't actually tell people about the bug. One of the things that the vendors asked for is they're like, hey, the fix, which is source port randomization, doesn't actually imply the bug, which is the ability of sibling names to overwrite TTLs. So how about we just release the fix and have a month for people to apply the patch? I don't know, that hasn't really been tried before. Let's go ahead and try it. And for about 13 days, we did in fact manage to have the fix out without the bug. Now the secret to realize is every time someone puts out a patch, other people go ahead and reverse engineer it to find the exploit. So that is just totally normal, totally regular. It is unusual to have this partial disclosure model. And the reason why it's unusual is because it totally lets people lie. People can totally be like, oh yeah, I have the biggest bug in the world in this name server, but I can't tell you what it is because it's a big secret and it could really hurt the internet. And I mean, it's a huge issue. And as we've seen lately with the whole Satoshi thing, people lie. It's a thing. And not only did I go ahead and validate the whole lying model, I didn't have any other hackers on board, right? I kind of considered myself the authority in DNS. I was like, okay, I've got Microsoft on board representing companies, and I've got ISC for the networking community, and I've got all these governments, and I'm the hacker. How much more validation do I need? And it's like, yo, you can't validate your own hack. You know why? Because everybody thinks their hack is the most beautiful hack that ever did hack. And so you can't self-validate. It's like dev and QA being the same guy. It doesn't work. I kind of screwed it up a bit. It happens. Learned from the experience. If I was ever to do anything like that again, I would definitely have other hackers on board.
What was the reason you went directly to the DNS community versus going to the security community or even selling the hack?
Well, the security community doesn't write patches, right? Or more accurately, when they do write patches, no. I went to the people who wrote the code that needed to go ahead and get fixed. And those were the authors of these name servers. There are many features that they wanted to implement. 10-second override of Google.com, not one of them. I remember, so I was, like I said, I was actually at Microsoft consulting at the time. And I'm one of the few people who's gotten to work his own MSRC case. Outside Dan has said this. Inside Dan is replying with that. It's kind of an interesting experience. But I finally had to meet with the guys who actually validate incoming bugs. And they're like, you know, as much as we trust you, we actually need to see this running. And I'm like, no problem. Set up a network, set up a server. I'm going to destroy your server. And they went ahead, they got the approvals, they got a system set up, they put it up in front of me. I mean, it had to be something that I had no control over, right? Like, it had to be, like that Satoshi test, like, you know, go sign something. It's like, all right, go wreck this. We know you had nothing to do with building it. I'm like, all right. And it was like 5 seconds. And the look of the guy's face, oh, that actually works. I'm like, yeah, it really actually works. And then the machine started going.
Cool. So before you found that, you were doing tons of other research in DNS. Can you tell us about that?
You know, it's just like an interesting protocol. It's this foundational technology that is so misunderstood and so barely understood. I'm in this room with like 200 engineers. And I'm like, all right, guys. I mean, these are software developers every day putting out tons of code. How many of you guys have dependencies on DNS? 2 hands go up. And I'm like, okay, let me rephrase the question. How many of you guys think when you put Google.com in a string anywhere that something is going to happen that goes to Google? Then like 198 hands go up. We have this problem that DNS is super foundational and it works too well. What do I mean by that? What I'm trying to say is web servers go down all the time, which means organizations develop competence in what's going on with their web infrastructure. DNS just works. It's just super reliable. And so you've got like a guy and a half at every large org that understands DNS. That's about it. And all everyone realizes is if they go ahead and mess with it like they try to firewall it, here's what happens, because I've seen it, and I'm sure most of you have too. Somebody messes with DNS, and it looks like everything is great. And eventually, something breaks. But it's not like there's any error handling down there. It's just some random thing breaks silently and puts errors in like, I don't know, some Tomcat Java string somewhere, and it's like broken for days. There's this giant epic misadventure to figure out after all of this stuff. Oh my God, those bastards broke DNS, and that's what happened. So by the time it gets back to the guy who made the issue, he's caused such a fire, and he's probably fired. So that is why organizations have heard, if you just don't mess with DNS, DNS just won't mess with you. And as good as this sounds, it also means that when we want to do interesting and important things with DNS, like use it to fix our entire cryptographic framework, there's actually a dearth of competence in the space. People don't understand the technology well. The technology is not advanced as well. I mean, how much have web servers changed in the last 15 years? How much have they changed in the last 5? We've seen a lot of technology growth in other areas. This foundational technology being bedrock, you know, it's got a lot of old stuff on top of it. Getting in the way. Well.
So you've been doing really cool research, and indirectly with Merrick, who is somewhere in this room.
Is Merrick actually here?
Yeah, Merrick's here.
Merrick, where are you? I love it. Even when I finally get to see you, you're guarded by 2 people and I only see a hand. Merrick and I co-worked on something proxied through a mutual friend / co-worker, but never actually got to work together directly. So wait, where are you?
Merrick is here. He's probably through the column for you.
Okay, there you are. Thank you. Your work was great. I totally understand where you're coming from. Your work was great.
Yeah, so you guys worked on the Glibc vulnerability. Can you give a quick background?
Okay, so this was, I've seen a lot of weird bugs in my day. This was the weirdest. it's, okay. Linux needs to go ahead and do some DNS resolution. DNS is a multi-tier platform. So you have like the concept of, wow, it's a lot of work to run around the internet to go resolve a name, especially if you're a machine from 1983. Let's split the job. You have your stub resolvers, random clients. They go ahead and they do DNS lookups. They don't run around the internet. They ask some other person to do that, a name server. It goes ahead and goes to the routes, goes to the TLD servers and whatnot. Split job. The stub resolver, the thing that's just doing a simple lookup, ask a question, get an answer, in Linux is part of the C library, Glibc, and for the last 8 years it's had a fairly catastrophic bug in it. Really kind of strange one. It's not in terms of parsing any particular bytes. It's in the error handling when it tries to get data and then it doesn't. And then what does it do next? If the right sequence of events happens, you get really, really straightforward memory corruption. Unusually straightforward in the modern era. So this was found independently by Google and Red Hat. They went ahead and ran around and made some really good patches, did some good engineering, made a release, and here's the thing. It's a horrible bug independently, where it's just like if there's an attacker between you and your name server, your host. It would be a much more horrible bug though if you didn't have the attacker didn't have to be in the middle. If instead of man in the middle, it was man in the end. If just looking up badguy.com caused arbitrary code execution, that's not a normal critical vulnerability, that's a worm. And we haven't had a lot of worm class bugs in some, like basically in several years. And Red Hat and Google had no idea if that was possible. It's like Red Hat's attitude is, it might be, and I quote from the advisory, we did a back of the envelope calculation. You're not going to pull out the envelope for a worm? Are you joking? So now you had this incredibly weird discussion of me as the researcher challenging the vendor and saying, no, really, is this wormable? And the vendor's like, probably yes. And I'm like, probably's not good enough. And that's when I realized the very interesting thing, which is that we have a gap in the way that we deal with vulnerabilities. Nobody's actually incentivized and actually has the staffing to figure out not just what's the issue with the code, but what's going on with this code in terms of how it impacts the world. So I go on this like massive 48-hour, oh my god, we've got to figure out what's going on here, research endeavor. And one of my friends who's actually was subletting at my warehouse works at CloudFlare, Jamie Cocker. So she goes ahead and she's seeing me like going at this thing, getting a lot of really good context. What we ended up, normally when you research a bug, either you know it's going to be really bad or you know it's not going to be really bad. And this is this weird thing where even after 48 hours it was clear we don't know. But we can't rule out either case.
I had a giant rebuttal to Dan Bernstein, and like I think it was like 2011. Guy did not reply because among some of the many examples, people are like, "Oh, you know, DNSSEC has bigger replies and makes amplification attacks terrible." You know what does not need DNSSEC's help for terrible amplification attacks? DNS. Believe me, that we're already there with no deployments whatsoever. Turns out orthogonal layers.
The reason DNSSEC is interesting is, so you have to look at what is the alternative to DNSSEC. Okay. Why do protocols scale across organizational boundaries? Why did all 200 of those hands go up when I said google.com in a string? Every time you want something to work across organizational boundaries, you ask DNS to go deal with it, and it does so well you don't even think about it.
When you don't have DNS, like when you're trying to do key distribution, all of a sudden, all you can think about is key distribution. Welcome to PGP and why it's really hard. You know why PGP is a train wreck? It's because you have all these situations where the software author has to go, I don't know what to do. Maybe the user can help me. Yeah, that's the deal. And then it's like, okay, well maybe the user can't, we'll have a key server. Which key server? Okay, how do you find the key server? DNS. Shocking. Which one? I don't know. Ask the user. So you know, the deal is that you even look, so okay. Here are your choices. You can use DNS. You can use some guy, which by the way for the CA system has become Let's Encrypt, which I think is great and wonderful. It's still some guy. The alternative to DNS always looks like massive centralization. Just how it works. And then if you don't go with that, you go back to something that just is the CA system. Okay, some guy might agree with us, how about we have 20 guys? And seriously, 20 guys love getting together and, you know, being the cabal that just consistently makes money forever. What DNSSEC does is it says, look, we've got a distributed, delegated environment where the participants in it just don't make much money. And isn't that great? You don't think I'm right? How much money do you think Google or Apple or Microsoft have paid ICANN for Google.com, Apple.com, Microsoft.com, whatever? It's like nano pennies on the dollar. You couldn't get a smaller share if you tried from a gatekeeper. Because that's just the model. That's why DNS won. But we're not able to use that really elegant, really straightforward delegation model for cryptography because we haven't had it in there. And so key management has been a disaster. DNSSEC would fix that if we could trust governments to keep their finger out of the system. Thus it being really problematic that they're on a warpath against cryptography. How I go out there and tell people, hey, we've got like the system that since 1983 has shown itself able to do delegated, distributed trust, but it depends on you not messing with it. Now they're messing with it. Now we can't get trust. Now we don't have cryptography. And apparently that's a good thing for some people. I don't know. I just like things not to get hacked all the time.
Are there other questions?
I have one, but it's from Swift on Security.
Oh no. Oh my
Please
God.
sing the answer.
What's the history of internet-scale multi-vendor coordinated disclosure? And was that a new concept back in 2002 or when you were dealing with this particular you're talking about?
All right, so just in case people didn't hear that, like on a live stream or whatnot, the question is, what is the history of multi-vendor disclosure? And I'll be completely frank, at the time I thought this was somewhat unheard of, but then I realized it's more just, it happens a bunch, just people don't brag about it as much. Like for example, like the University of Finland, Aioli, I can never pronounce their name right. They had a thing called Protos, and what they did, or Protos, they basically did some of the earliest protocol fuzzing against ASN1, which if you ever look at ASN1, it is basically like a prayer to please exploit me. Every single byte wants you to die. I'm not kidding. Every byte is a flaming boom. There's nothing else like ASN1. So they went ahead and fuzzed SNMP implementations in like 2001 or 2002, and it was not pretty. Nothing had been fuzzed back then, and it showed horribly. So, my stuff in 2008 was certainly not the first multi-vendor stuff that went out. I don't know that there's anything that had this big synchronized fix though, and I think that this stuff really had to, and just because if nothing else, you at least needed to figure out the code execution exploit for each of the SNMP things that you were exploiting. My thing was just like, hey, Google comes to me now. Done. And it worked reliably. You didn't even need to know what your target was. Now that that's a long-term stable thing, believe me, the Android stage fright stuff is not made less scary because you have to figure out what Android phone you're exploiting. But there's certainly been a number of bugs that crossed vendor boundaries. This was just a very public one that required a lot of ultimately public coordination that really generically touched a lot of systems blindly. I thought it was a lot of fun. I don't know, I mean, I was happy about the coordinated response. The press absolutely got out of control, no question about that. But hey, like I said, you live, you learn.
So we've talked about DNSSEC, so we've talked about what needs to be done with DNS and integrity, but what needs to be done about DNS and privacy?
And I have a controversial opinion here. DNS is not a layer that privacy works at. It is just not. You know why? Because you talk to a name server and you say, hey, I need to look up Google. And even if you go out and have an encrypted link to your name server, something's gonna go talk to Google. That's just how DNS works. Something needs to go ahead and talk to all these hosts in the chain, be like, hey, I need to look up google.com right now. Like, DNS privacy is along the lines of, how can I be private even though I'm not in a VPN? Even though people can see some of my traffic, I still want to be safe. You want to be safe, you need to encapsulate your traffic. And these false models of how the privacy can work, they just don't impress me. Stuff like, okay, so you look up google.com, now google.com's in the cache of that server and something can check. You know, I want to say call it half-assed security, but you know, there's an ass and we got like half of it. Okay? It's not how it works. I see a lot of this stuff with sandboxing, which is a thing I've been playing a lot with. It's like, well, you know, I blocked this call here, this call there, I moved the ball. It's like, no, you've got to get a sufficient level of coverage so you've actually blocked some class of attacker. And privacy at the DNS layer between a stub and a particular name server, it's just not blocking a sufficient amount. You want to have some privacy to the user, you've got to get the user onto a network they can trust. Because DNS fundamentally, as a distributed system, is going to distribute in a non-equal manner where the lookups that it's doing. That's just how the system works, I'm sorry.
That's really interesting.
Any other questions?
Dan,
We got another question.
what are your thoughts on EDNS client subnet?
On what? Oh, EDNS client subnet? I like it. So EDNS client subnet, if we're talking about the same thing, is a way that that name servers can know roughly who's doing a lookup so they can do geo-targeted replies. Good, because as it happens, doing geo-targeting via DNS makes people's internet access better. And it's not, you know what you do after a DNS lookup? Generally, you connect to that endpoint. That's not like a secret to that endpoint. You can go ahead, here's the thing I try to remind people. Just because you can engineer something doesn't mean you fixed anything, okay? It's like, oh no, someone might find out what you looked up. Yes, I know, you were looking them up. I was trying to talk to Google. It's okay. Let Google give me the fastest service they can give me. So, what's the alternative, right? You do a lookup in DNS, and then you connect to the wrong address, or you have like an anycasted address, which is a deployment pain in the butt. The whole point of the internet is that it's not a pain in the butt to put things on it. That's why this internet won. There were lots of other attempts that didn't. This one worked because it worked. So, we shouldn't do engineering things for the sake of engineering things. We have to actually say if there's reasons not to do something for privacy or for security, there's a bar. We have a problem. And you know, security has really screwed protocol development. It has. We had a whole bunch of really insecure code in the 90s that were like, oh my god, we have got to keep RPC stat D off the open internet. So what are we going to do? We're going to go ahead and we're going to make all the other old code that that used to be on different ports. We're going to make it not work. And instead, the only thing that's going to function is HTTP and HTTPS. Haha, we've secured things. Now we tunnel everything over HTTP and HTTPS. And we're just getting these like sedimentary layers of, oh, we can't even use HTTP anymore because too many things are inspecting that. Now we have to do HTTPS. Oh, we've got like, other things that we're trying to route over it. We have like bidirectional communication. But let's put in, was it ALPN, the alternate layer protocol stuff? Like, and you know where else you see this, of course, is in cell phone protocols. And you know what's a freaking nightmare on? Cell phone protocols. What you have when you get all of these sedimentary layers is you basically get agglomerations of bugs, which is the long, hard path to return of ASN1. So I'm really worried about this. We have any other questions? Anyone want to do anything cool with DNS and don't know how? Go ahead.
What's the situation of NTP and DNSSEC?
Oh, the question is, what's the situation with NTP and DNSSEC? So you got like a chicken over here, you got an egg over there. Remember that problem? Here's the problem, okay? NTP really needs good cryptographic keys. And as it happens, the best way to get cryptographic keys is DNSSEC. However, DNSSEC needs absolute time in order to function, or you have replay attacks. So, where does DNSSEC get its time so that it can validate the keys for NTP? How do we untangle this? Now, I actually released a DNSSEC proxy back in 2010 called Freebird. And Freebird's basically, look, the problem with DNSSEC, there is one, is they thought everyone should do offline keying. You should basically do a pre-processing stage, and then it's like flat files, and that's what you distribute to the internet. How long have we not been doing that with web servers, okay? Offline stuff, flat files is not how the world works, but it's how DNSSEC needed to work because it needed to support the web, it needed to support the roots, it needed to support the big COM file, what's it called? The big top-level domains like COM. For everyone else, this is a miserable way to operate, which is why everyone who's tried to deploy DNSSEC was like, why am I sitting here waiting for this giant pre-computation phase? Turns out, not actually necessary. You can have a key online, which sounds a lot scary too, and realize, oh yeah, that's how SSL works, that's how SSH works, that's how IPsec works, that's how things actually work. You do have a lot of online keying. Once you have online keying, once you have online signing more accurately, you can have a resource that the internet runs, and believe me, it runs the roots. It's not like the internet doesn't run things. You can have a resource that the internet runs that gives you coarse signing. Now, what is coarse signing? NTP gives you time down to the really down to like some number of nanoseconds. DNSSEC does not require nanosecond accurate time. It does require absolute time within some number of seconds that can't be replayed. You get that with a nonce request. So you would do a request to something like randomvalue.time.arpa, which is actually implemented in Freebird. You would get back a signed value from some signed area of the, it's not root key signed, but .arpa is signed and .time would be signed. That's what you would use. You would not pay attention to the timestamp of that particular signature because you know it's a dynamic signature. You don't need time in order to prove it wasn't replayed. You already have the replay protection from somewhere else. And then that bootstraps DNSSEC time, and that's how you go ahead and bootstrap the keys for NTP, and now our long time nightmares over. But it requires being able to talk to people about DNS and it not being a thing compromised by the feds. Like, I can't emphasize enough how this encryption debate is hobbling our ability to develop new, safe, usable crypto protocols. I cannot believe that we are actually debating that perhaps things are too secure. Are you joking? Have you looked outside? Any other questions? Over in the corner.
Do you envision a time within our lifetimes where we'll maybe progress to something better than DNSSEC? Do you think we have the internet goodwill to actually try and replace DNSSEC?
So the question was, do you think we'll have the internet goodwill to replace DNSSEC? And the observation I'm going to have is people just don't have very rational arguments against DNSSEC other than Ooga Booga Feds, which unfortunately is an increasingly rational argument because of Ooga Booga Feds. Look, DNS works. DNS works better than anything any of the complainers about DNSSEC have ever written. Okay? This protocol works so well, we literally have not enough people who understand how to do things with it. Like, it's just really reliable. DNSSEC servers need to be written a little better. We really need to have like a widespread move to online keying. We need to have signing by default that can then be absorbed. Like you should just, like the next version of Bind should just sign stuff. It's okay. We'll learn how to use the signatures. It is important to realize that there's a lot of loose binding. Not just in DNSSEC, but just in the way the internet works, okay? You bring up a server on Amazon and it's not connected to DNS. Why? It's not like Amazon doesn't run Route 53. But when you look at it, there's just a whole bunch of things that don't actually really talk to each other. You bring up a server, it has a name in EC2, the server doesn't know that name even though it's right there. That name is not linked into Route 53. You shut down the server, you bring it back up, the IP address has changed, nothing is notified. A lot of how this internet works is nothing automatically talks to anything else. Everything needs to be glued together because maybe you'll want to glue it together differently. And indeed, we do glue things together radically differently today than we did 2, 5, 7, 10, 15 years ago. So it's not wrong. The problem is that this dynamism of how we glue things together has issues with something like DNSSEC. Because if we're now not just declaring IP addresses, but declaring keys, like the parts of your systems that have cryptographic keys have to stay in sync with DNS. It's not like a new server can just show up and randomly be at the same IP address and everything's okay. No, the same IP address alone is not enough. The same IP address is the same destination. The lights are on, but now someone different can be home. And before that wasn't a problem, but now it actually can be. Now, it's not like we don't have that problem with everything else, it's just a lot more self-contained, right? Like if you bring up another server at the IP address and there's no certificate from a CA, well, it's really obvious that no certificate as a CA, you have to do something as the administrator of that server. But now let's say it's like you have a value you have to update in DNSSEC. Now you got to talk to the guy who runs DNS, or you have to be someone who understands DNS. I always say every project needs to be understood as how many meetings you need to have to get it done. The moment the web guy needs to have a meeting with the DNS guy, that's a meeting. And that's one more than zero. So it's all about this, like the great thing has been seeing DevOps actually happen as a field. We are all now running systems too large so that no meetings can happen. Now it's like, there actually have to be people who are specialized in making this sort of glue. Now I'm not sure people aren't sniffing that glue, but at least the glue is happening. And that's what gives me a lot of, like when you have the pushback on DNSSEC, it's like, oh no, I'm gonna need to have more glue between things. Like, well, yeah, but you already have glue between things, I hope.
Cool. So what do you think, what do you think needs to be done about email security? I'm curious especially about Dane.
Look up the key and move on with your life. Okay? Like, all of this stuff is not actually hard. Okay? Like I said earlier, the reason PGP is hard is because it has to keep going back to the user. If you just didn't, if you had a single canonical source to go back to, as opposed to some mess of systems, look, you should just be able to go to google.com and ask for the key for whoever and move on with your life. I actually wrote a full-on implementation of DNSSEC-based key retrieval for Outlook 5 years ago. And you know how long it took? It's not like it was one like big epic adventure. It took like a few hours. You know why? Because Outlook said I need a key, and I'm like, I've got you one right here, and it comes from my domain, and it's signed, and no one else can do it. And guess what? Hard problem, easy, done, move on. That's, you know, stop thinking about we have a hard thing and we're going to keep it hard. No, take the hard thing, make it easy. When anything else needs to work across organizational boundaries, you look it up in DNS. When we need cryptographic keys for secure email, let's go get it out of DNS. Can't trust it because there's no crypto? Fine, let's make crypto part of DNS, which is what, until recently, the Fed spent so much time building this. And it works. It works so well. It works embarrassingly well. I'm serious. Like, all that code I wrote for Freebird was in a couple of months, and it does stuff that we haven't pulled off otherwise 6 years later. Turns out if you use the right architectural approach, things work better. So that's what we should do. We should just get our keys out of DNSSEC and move on with our lives.
What's your question?
Dan, do you bit squat your own domains?
Bit squat. Who here knows about bit squatting? Bit squatting is amazing. So, I don't know if you guys know this, computers are buggy. And sometimes not like instantly buggy. Sometimes their bugs take a while to expose. They're like bugs that happen 1 out of a billion times. But you know, your CPU's running at a couple gigahertz, you've got a bunch of them. 1 out of a billion times happens like a couple dozen times a second. So what this means is that sometimes you just get bit flips, and a lookup for Windows Update becomes a lookup for Wanda's Update. And what people will do is they'll just go ahead and register all of these 1-bit off names and see who comes to them. And the number is often not 0. And it's one of the reasons of many that you actually do want to have something like DNSSEC, because checksums aren't enough. The surprising thing is that for all of the, oh, you know, we've got all this math here and it like protects against random corruption, no. Random corruption in the wrong place does not actually, like, you can have that bit flip between a checksum receive and a checksum send. Not just it can happen, you register the domains and in comes that hardware. That stuff is completely, that stuff doesn't happen nearly to the degree that it can. It can still happen through something like DNS, but it happens way less. So when you have like all this validation, it's not enough. Like, here's the thing, you can have the flip for Wandas, but it's not going to end up working for the endpoint. It's not like all the endpoints, it's not like all the hosts in the middle can all alter stuff.
So do you bit flip your own domains?
I do not bit flip my own domains. You know, I actually want to take a bit of that back, because I'm going to be skeptical about myself for a second. I think there's certainly less stuff that cryptographic signatures are better than mathematical checksums. But the sorts of things that cause the mathematical checksums to still fail are in fact the sort of things that still cause cryptographic signatures to still fail. When you can't trust the bits of, we like to reduce our systems to logic. Say, you know, this is always a 1, therefore we can reason based on it. And we do not reason from, well, 99.999% of the time it's a 1. We just don't do that. So anyone here familiar with the Rowhammer class of vulnerabilities? Rowhammer is basically like, hey, we're just going to go ahead and like, you can literally think of RAM like a bucket of electrons. Well, what happens if you keep sloshing a bucket? Well, some water will spill out. Literally electrons can spill out into like neighboring cells. Bad things happen. So one of the conclusions from Rowhammer is you can cause these things that break out of your logical model and your logical frameworks. One of the conclusions is, wow, under enough stress, enough weird inputs, any system can break. And bit squatting can really be thought of as a Rowhammer brought to you by cosmic rays.
Omar, how are we on time?
I have to warn you, I can do this all day.
You can. I mean, we still have another 10, 15.
Cool. I want to talk to you about the government, and then we have a speed round, and we can take a few more questions.
All right, I
How's
promise
that
no
sound?
more jokes.
Right before this week.
Not really.
There's a picture. And it's more like explosives. Just
Okay.
Uh-oh.
We only, please do not promise no more jokes. Cool. So, you were really involved in the SOPA and HIPAA cases.
Yeah.
How did you get involved? What was your involvement?
You know, they really started saying, hey, why don't we stick our finger in DNS, and that's how we'll regulate the internet. And at that time, it had been a few years since I'd worked with the various actual fathers of the internet, Steve Crocker and Paul Chain. And actually, it was ICANN contacted me. It was like, hey, do you want to get involved in protecting DNS? And that had been a thing for me for a while. So I'd never, obviously I'd interact with like various like political parties or political bodies, but I'd never actually gone in to advise. And I said, okay. And we put together a document that really described this is what happens if you take the foundation of the internet and manipulate it. Or at least the foundation of the internet's inter-organizational trust. Let me caveat that. And it was actually one of the more fascinating experiences of my career, and let me tell you why. DC is a little interesting in that they get a lot of people who work with people who know how stuff works, but they're lobbyists. Their job is to take a bit of information and kind of just like shove it in there. As an actual engineer, as someone who actually went ahead and works with DNS and went ahead and broke it, like, I was able to get a lot of meetings I didn't think I'd get. And I finally found out why. It was because even if it was the other side of the aisle, even if it was the other side of the debate, they were just so happy to have the engineers in the room. For them to be able to say, okay, I may not like what you have to say, but I'm pretty sure when I ask you something technical, you aren't going to be like, well, I'll get back to you. You're just going to tell me. And maybe I'll only understand 5 to 10% of it, but whatever you actually do tell me will be the technical, accurate reality. So it was a really interesting adventure of going around, talking to a lot of people, briefing a lot of people, being on panels and having debates. And it was very fun being like the engineer having a debate versus the lobbyist, because it's not going to work out too well. We ended up winning the SOPA and PIPA debates, or at least not because of us, I don't think. How much time do people spend on the internet? Like, you got to realize, like, when Wikipedia and Reddit went black, like, the degree of impact in people's lives was actually really significant. I was at this great, ICANN doesn't actually run the internet, but a bunch of people think they do, to the point where they'll just sometimes run town halls for the people who think they run the internet, because why not? It's cheaper than taking complaints about why they're not running town halls. It just is, like, fine, we'll gussy on up. So ICANN had this thing, and this guy goes up and says, you know, hi, I'm from Egypt, I just deposed my government. And then like 10 minutes later, the next guy goes up and says, hi, I'm from the former Egyptian government, that guy just deposed me. It's just, there's a reason I was telling you this. No, it's interesting seeing like how the world, this was the point. The guy from the Egyptian government had the greatest comment. It actually was like, made the entire event worthwhile. He's like, we never should have turned off the internet. You know why? You realize how many people now had nothing to do but go down to Tahrir Square? When Reddit and Wikipedia went down, you have any idea how many people had time to complain to their congressman? All of them. So anyone deserves some credit. Wikipedia and Reddit deserves some credit.
How is testifying before Congress?
That I'd actually done a few times. They backed off on DNS literally 3 days before I was scheduled to testify. I've spoken on to a few subcommittees at this point. It's, what can I say? You're asked some questions, you give some answers, you tell the truth, always.
What do you think is the right way to bridge the gap between the technical community and the political one?
Now that's actually a really interesting question. There's software is re-architecting society. It just is. We are changing the way that people do business and people meet. I think Swift on security, who spoke earlier, was like, wow, hey, wait a second. Like, algorithms and OkCupid are pairing people together. The AI is breeding the next generation. Like, we really are like re-architecting society here. And as it happens, like, it is actually true. Engineers don't have all the context of what everyone needs in order to have like a society people want to live in. The flip side of us having the freedom of building everything is the surveillance guys also have the freedom to build everything. So, we're not the only engineers who are doing stuff here. And the policy people are kind of in the middle. They are actually the people who are professionally asking, well, how do people want to live? Like, what is the society what are the rules? And for a long time, they really didn't have a lot of technically aware people. And that's changing because we've just had a lot of people now grow up with the internet being background radiation. I remember 5 years ago, I think my absolute favorite comment, DC has this thing where if you are talking to someone and they have no idea what you're talking about, you have no idea they have no idea what you're talking about. They are super good at nodding, repeating back to you. This is a practiced skill, which I was not aware of at the time. But I get this amazing feedback at one point, right? Like, it's like weeks later, I think I had a good conversation with this one aide, and the feedback was, this guy, he's talking to me about the Pirate Bay. Are there like pirates in a bay? Is this guy crazy? What is he talking about? I would have explained, but apparently that's just not a thing that you're just supposed to know. It's a thing, so.
And then my last question about government is, what do you think the government's role should be in securing the internet?
I believe there is a role. I do. If there is a role for government securing the internet, it's to be more than the biggest and baddest hacker in the room. Okay? You can do more with the internet than share information and hack more things on it. There's, we do have like the interstate highway system. Okay? Government has this property which needs to be respected, which is they can think on really long time scales. DNSSEC exists today because of Doug Mon, who's right now at the Department of Homeland Security, who carried the torch for the technology for 10 years. Okay, what company have any of us worked for that has like a 10-year plan? It doesn't exist anymore. So, I really do think that in terms, we have this problem with infrastructure. We're not terrible at building it, but we are awful at maintaining it. But if anyone's actually really thinking on the timescales that you need to think about for maintenance and upgrades and scaling things up, government hasn't done a terrible job at it. What we have as a problem is that there's not firewalls around the people who are doing genuinely good work. Okay, NIST was compromised by the NSA. Very good cryptographic work comes out of NIST, and Internet Protocol engineers are just not adopting it. We have replaced NIST with DJB, with Dan Bernstein, a guy. And I'm not saying Dan Bernstein's not a genius. I've spoken well of him many times last hour, but we don't have the guy who works on cancer. Okay? We have like institutions. This is a good and proper thing. And we need to protect the institutions that do good, give them the opportunity to do more good. We need something like the NIH for site. We need something where we're not just debating. The debate about what to break is so loud and so noxious, it is choking out the debate about how we are going to spend resources as a society fixing things. There's just too much that's some guy's duty and responsibility to manage. We can do better than that. Stuff's too important. We have our society built up now. That's right.
So my guess is this is the image. Omar, do you want to explain?
I don't want to explain. I would say, tell us more about this.
Well, so among other things, I'm partially responsible for this image. Do you know that?
I didn't know it was actually you that was responsible for it. I thought you just had a heavy influence on it.
So when I say partially responsible, so 2004, and I'm friends with this guy, Barry Lyon, or Barrett Lyon. I was one of the first people to do really widespread, really loud internet scans. And I basically did it from the perspective of, hey, I'm a good guy, here I am, here's my cell phone number, here's my email, white hat. I plead the mercy of the court here. It turns out that works really well. It just does. No one ever asked how I had all that bandwidth. So DDoSes were still a thing, were already a thing in 2004, and there's a company named Prolexic, which some friends of mine worked at. And Prolexic had these giant, enormous pipes for when the DDoSes came, and then they would actually have people handle the DDoS, and the site would still stay up. DDoSes don't continue. Floods don't continue if they don't work. So I had all this bandwidth, and it was good. Barrett was doing some stuff with massive scans as well, and was trying to figure out how to take the data and make an image of it. I had, at this point, kind of a thing. I will go through phases. I was in the middle of my bioinformatics phase. I know other people go emo. I go nerd. And so this is actually the output of LGL, Large Graph Library, a library that was specifically set up to graph the human genome and all of its complex relationships. And he was dealing with stuff that scaled to tens of thousands of nodes. And I'm like, no, Barrett, you got to use this thing. This is what you use. It takes forever, but the output's like that. And it shows up, and it's totally beautiful, and I think nothing of it. And I'm wandering through Vancouver, and I look on the side of an art museum, and I'm like, oh my God, that thing's like 70 foot by 70 foot. How did this happen? And I don't care, because look, it was almost entirely Barrett's work, and all I did was help him go ahead and make it scale out. The internet is big. This was it in 2004. It's way bigger now. This is what we call in graph world a hairball. You can look at it, it's pretty, but it doesn't actually mean anything. But yeah, this is what we gotta fix, guys. Everyone ready to go? Hit your fix button and move, because this is what we built our society on. A giant hairball mess of interconnected systems that work better than anything else that happened before.
Do the colors have any significance?
Yeah, the colors in this particular map, I think we're referring to backbone. So I think like one of these is layer 3, one of these is AT&T. I could be wrong, but they're not random. They're very much talking about from a particular, or at least from various vantage points, this is the sum of trace routes. Not that trace routes are necessarily the most accurate thing, even then, but this was the result of trace routes. Where I think, I do actually think what I'm going to end up doing at some point is, so I built a streaming graph visualizer. You can do that. You can actually take these functions and you can have it add and remove nodes over time. And it turns out that looks amazing and actually has explanatory value. So you basically say, we're going to show a graph of the last 10,000 nodes and what they're linked to. And you just like let the stream run. So I think I'm going to let that actually work for you're browsing the web and show a graph like this, not across the overall internet, but across like the last 10,000 hops that happen. And I think that animation will be pretty cool.
This is so cool. Cool. Our last section is a speed round.
All right.
We have a really cool slide for it.
Okay.
Are you ready?
What could possibly go wrong?
It's really cool. It's cooler than this thing. Ready?
Cooler than the
Look,
internet.
look. Oh, okay, just kidding. Okay. Your first email provider?
Netcom.
The first website you made?
etext.org for the Gutenberg project.
That's so cool. Vim or Emacs?
Then
Your programming language of choice?
changing but still no.
Okay. And the funniest thing you've ever done with DNS?
Oh, funniest thing I ever did with DNS, I mentioned this earlier. So, okay, okay, I know what the funniest thing I ever did with DNS was. I wrote the worst protocol that you should never ever do, and I'll tell you why. DNS, okay, so normally with like TCP, you drop a packet and you go faster, faster, faster until you hit the saturation point, then packets start dropping, and now you know you're going too fast. And you now have like a safe point because it was the fastest before it stopped dropping. This is not actually how name servers work. If you are tunneling traffic over DNS, you will just always have drops. At least this was the case on the name servers that I was testing at the time. So you might go ahead and speed up, speed up, speed up, and like you're losing 1 out of 10 packets, and you slow down, and you're still losing 1 out of 10 packets. You slow down, you're still losing 1 out of 10, and now it's like 1 out of 20, 1 out of 30. So I wrote this reliable communication protocol over DNS, and here's the game. You decide how many packets it must keep dropping. It's okay, you don't have to stop at 100%. You could say, I want you to keep going faster as long as half of them are still going through. And that is how I got so I made this scheme with live streaming audio over DNS. And they were just not impressed. They're like, you know, Dan, you can compress down audio pretty low. It's not surprising, a few kilobytes a second. You can't get anything really fast over that. And I'm like, I bet I can. So I ended up making this this protocol that just kept getting faster until I think I had a 75% loss rate, and that was how I ended up getting, I think it was 100 kilobytes a second, and Darth Vader doing Darth Vader doing the river dance from what is it called? Robot Chicken.
That's awesome. Amazing. Let's take a few questions, and then we can, if you have more questions, you can just come up to Jim.
Where would someone store DNS rootkey or chunk of it?
Where would somebody store what?
DNS rootkey. DNSSEC would.
My understanding is there's one on the east coast of the U.S., there's one on the west coast of the U.S., and then there's the one that's full of crazy fellowship of the Rings hype. It's weird. No. So there's a key somewhere in some undisclosed location. And these are people, by the way, who do undisclosed locations like properly. When we did this DNS root signing ceremony, it was basically a machine gun guarded cyber cave in Culpeper, Virginia, with a 279 stage process. I swear to God, like, it literally needed Gregorian chant, and the first smart card of the second half of the third key. Like, I mean, it was really bad. I'm like, what is going on here? And then I looked around, there were like representatives of like every government on the planet. I'm like, what am I doing here? But effectively, we have, so there's this one key, it's split into 7 chunks. 5 of us have to get together in order to bring it back together. I'm the American. The guy out in Britain is the one who talks about it every few years. And if 5 of us get together, we show up at the undisclosed location. We only go there if East and West Coast are unavailable. And join our keys like Captain Planet. Now we have a 3rd copy of the original root signing key. Which, by the way, if you understand DNS, you realize it signs approximately nothing. The amount of data in the root, this is the most reliably hosted, least actual amount of data. But it's actually super important because for the love of God, there's just one. It's not like the CAs where it's like, oh hey, Turkey wants in on this party. Like, no, there's just one root. Some of my friends were messaging the other day, like, wait, are the roots down? And I look into it because there's some website saying the roots are down. It's like, no, there's something called the public root, which is like a protest route run by a bunch of who the hell knows. And shockingly, even though they had 30 servers, all 30 were down. And they sure make themselves look like the roots, but you know what's not down? 30 of the real roots. You know what is down? 30 of yours. One root is awesome. Means you don't need to ask the user which one to trust. Because that's a disaster.
So China has a firewall. I read the Russians is the US getting a firewall?
So the question was, China has a firewall, Russia has a firewall, the US can have a firewall. There is a segment, especially the policy community, that thinks that the internet should be balkanized. There should be the Chinese internet, the American internet, the Russian internet, the Albanian internet, and remember the whole point of this internet is there's just one internet, okay? There's not like this massive gateway tax across, honestly, nation-state borders are organizational boundaries too. An internet that needs to have 180 different gateway traversals, and remember it's 180 times 180, or however many countries there are, is an internet that doesn't work very well. It's not work like it's been working. There's an argument that to deal with cybercrime, okay, the biggest way that we manage crime is, primary mechanism is geographic. We just make it so people can't interact at all, and therefore they can't commit crimes against one another. And if you actually look at law enforcement distribution levels, you have the highest level of law enforcement per capita at local, because that's when the most people are interacting, and then less at state, and then less at federal. And we all just kind of pretend international law is a thing that exists. We know it really doesn't. The internet that worked, the internet as we built it, is one that doesn't have this geographic property. You are as likely to receive communication from somebody in Africa or Asia or Eastern Europe as you are from your next door neighbor. And so that internet doesn't have a lot of the law enforcement or crime suppression mechanisms of the real one. So one of the policy attitudes is maybe we should make the internet as operate like the real world does, which is a lot more geographically focused. I think this has tremendous negative impacts on the global economy. I think it would suppress growth. I think it suppresses jobs. I think it's a bad thing for society. Like, look, we live in a massively geographically distributed culture, okay? Like, how many people are sending remittances back home? Like, people travel, and people have family in other countries. So the very model of the geographically constrained society and culture, I think, is an old model. But it is definitely something the policy people are exploring. And I don't know if it stops. I think the internet is people are trying to balkanize the internet. The flip side of government thinks in long-term timescales is they can do things that take 10 years to take fruition. That at any point, if they did it immediately, it'd be like, oh my God, no. We may turn around and be like, wow, hey, China has a bunch of IP, like the United States Department of Defense has a bunch of IP addresses, IPv4 addresses. And China one day may just be like, why are we having the US military have routable address space in our country? They might do that.
Let's take one more.
Namecoin, Evernym, is there any, have you looked at any of these, is there any reason to pay any attention to them? Is there room for innovation out there?
Wait, I didn't hear your question.
Namecoin or Evernym are these alternative, kind of complete alternatives to DNS in the future? Is there any reason to pay attention to them in your opinion?
I don't know, how much do you want PGP ported to DNS? Okay, seriously, this is what I will say. So Tor did an interesting thing. They said, look, we have a namespace, .onion. We're going to go through proper processes and we're going to ask, that .onion is a namespace off the TLDs that is not run out of DNS. It's ours. It's a application private namespace. We take it and we have claim to it by I don't know, de facto. People are using this namespace. Please don't step on it now that it's used. And you know, like, let me tell you how much we defend the undotted namespace. So like in corporate networks, you have a lot of names that don't have extensions. Let me tell you, if anyone ever got a .mail or .corp or .whatever, like, oh, it'd be ugly. So, do they actually have a .corp?
I think they have .corp.
If they ever put anything there, they will have given up completely on don't be evil. As it happens, that's hilarious because .corp is literally the domain most associated with Microsoft networks. So, wow, that's amusing. But yeah, the root operators know all the domains that really need to not be given out because they conflict with local namespaces. Because all those queries will show up there because of misconfigured hosts. So it's not like we don't know what not to sell. I would have assumed .corp had been on that list. I'm a little disturbed that it is.
I know because our .dev stopped working one day when Google started serving records for it.
That's not problem. I'll fact check you on that.
Okay.
I mean, Apple took back .local, so for MDNS.
I think .local has its own context. I mean, the question is when you ask the roots for the domain, does something come back? But just to focus on your stuff, I'm not, okay, Namecoin and these alternate coining things as a overlay to proper DNS, I think is, I think that's them squatting on an established namespace. Like you don't go to namecoin.com, then you gotta ask, am I going to namecoin.com or am I going to actual root DNS.com? And that's not a good thing. These things actually taking a private chunk of the namespace, figuring out how that could work, I think is actually an extensibility point that there's no reason to object to, but no reason to think is going to work out.
Dan, thank you so much. That was awesome.
Happy to help.